Hello, in this video I'm going to solve the following challenging problem on the topic of definite integrals. The function f is differentiable and continuous. Moreover, for all x in the closed interval from 4 to 8, f of x is not equal to 0. If f of 4 is equal to 1 over 4 and f of 8 is equal to 1 over 2, and this relation holds, then f of 6 is equal to. Pause the video at this point and give it a try to see which one of the given following options is the correct answer to the problem. This is a problem from Vietnam. It is an extremely beautiful problem. Okay, so now let us solve the problem. First time that I saw the problem, or actually didn't know exactly what to do, because you have only local pieces of information about the function, and you want to calculate of f at some point 6, but the relation that is given to you is an integral. An integral usually is being interpreted as the area under the curve, but I do not know anything about my function f, so this integrand seems so complicated. Okay, but if you see the structure somehow, this is a function derivative to power 2, this is a function to the power of 4. But I hope that you remember this formula that 1 over u, where u is a function of x prime, is minus u prime divided by u squared. Okay, so in other words, if I multiply this by minus sign, it becomes the derivative of minus 1 over u will be u prime over u squared. I know that this structure is not exactly that, because here I have second power for my derivative and fourth power for my function, but in this famous structure I have u prime, the derivative of my function in the numerator, and the second power of my function in the denominator. Okay, might be it is a good idea if we can calculate this integral for this combination. In other words, the question is that can I calculate this integral from 4 to 8, yes, but instead of f prime to power 2, I would write f prime of x and f of x and then to the power of 2 dx. Okay, so at this stage it is just to see what happens. It is a little bit of trial and error. Okay, the idea becomes clear a little bit later. So let us just, out of the blue, okay, try to calculate this integral. This should be easy for you, yes? If you want to do this calculation, you introduce a variable u, f of x, then you just do the standard trick in substitution. So you take du becomes f prime of x dx, and now your variable x is supposed to go from 4 to 8. So this means that your u variable goes, if x is 4, u becomes f of 4, and if x is 8, u becomes f of 8. But these are fortunately given in the problem. F of 4 is 1/4 and f of 8 is a half. So this means that this integral, so if you don't mind, let me call it I. This integral I now can be written in this form. Integral, instead of from 4 to 8, I will have from 1/4 to 1/2. And this expression becomes du divided by u squared. And this is a very simple integral to calculate. A primitive function for 1 over u squared is minus 1 over u. I have to run it from 1 over 4 to 1 over 2. So I put 1 over 2, it becomes minus a 2. I put 1 over 4, it becomes plus 4. And the integral becomes 2. So this integral was easy to calculate. Yeah? So let me write the information that I have. Might be it will help you. So here I have integral 4 to 8. And then I have f prime of x squared divided by f of x to power 4 dx. This is given to you. This is what we calculated ourselves, that 4 to 8. And then I have f prime of x and then f of x to power 2 dx. is just 2. One thing I can add here, you will see why this will be important. What will be the integral from 4 to 8 of this expression, 1 over 4 dx? The reason I'm interested in 1 over 4, because I want to make the complete square for an integrand. You will see how. But let us calculate this one. That is extremely easy to calculate because integral of dx is just x. I run it from 4 to 8. The difference is 4. That 1 over 4 cancel that one, and I get this expression. Okay, now interestingly, you see this one minus this one plus that one is 0. But why do you think it will be useful? Okay, be patient. Let me write it down. That one minus this one, integral from 4 to 8, f prime of x to the power of 2 divided by f of x to the power of 4 dx minus the middle one, 4 to 8, f prime of x, f of x to power 2 dx, plus the third integral from 4 to 8, and then 1 over 4 dx. This is 0, yes? 1 minus 2 plus 1 is 0. But what is the benefit of that? I can write these three intervals as one integral, yes? So I can write integral from 4 to 8, and I will combine the integrands dx equals to 0. The integrand of the first one, so f prime of x to the power of 2 divided by f of x to the power of 4 minus the integrand of the second one is f prime of x divided by f of x to the power of 2 plus the integrand of the third one is plus 1 over 4. Now hopefully you understand why did I do that, because I was trying to engineer some complete square. Do you see it's a complete square now, yes? Because I can write it as integral from 4 to 8, then this is a squaring pattern. I can write it as f prime of x, f of x to the power of 2 minus a half totally to power 2, yes? The first one squared will give me this one. 2 times the first one times the second one with the minus sign gives me the second term. And this one squared gives me the third one. So what I have done is correct. So this integral is equal to 0. So that was the reason I was trying to do those things. But why this is helpful? Because we have a theorem when you study integrals. If g is defined on the closed interval from a to b, and you already know that for all x in this interval, g of x is greater than or equal to 0, and g is continuous. I forgot to say that is the most important part, by the way. G should be continuous on this interval. Above all of that, you know that integral from a to b, gx dx is 0. You see, if I have a continuous function on this closed interval, and I know that it's always non-negative, but I know its integral is 0, then it means that this integrand is identically 0 on that interval. In other words, for all x in a and b, g of x is equal to 0. Okay, so that is the theorem that was in the back of my head, so that I wanted to use that problem. So is it possible to say it here? Consider this function. Give it the role of g of x. First of all, this is non-negative because of the even power. Yes. Is it continuous? Yes, because it has been mentioned in the problem that f is differentiable and f is continuous, of course, and f of x is not 0 in that interval. So this means that f prime of x, okay, so I have to be careful because there is no guarantee that this function is continuous, yes, because I know that f is continuous and not 0, and the function f is differentiable, okay, but there is no guarantee the derivative of the function is also continuous. So I'm not sure if the designer of the question cared about this or they have a different way of solving the problem. Okay, please leave comments below, because you know I want to say that this function is continuous. I know that a constant function is continuous. I know that f is continuous and not equal to 0. I know that f prime of x is do exist, but I do not know that f prime of x is continuous, because for using that theorem I need to know that this is continuous as well. Okay, so that is a problem actually. I haven't thought about that before, but now but let us imagine that f prime itself is also continuous. If that is the case, then I can conclude that expression. I can use that theorem and conclude that f prime of x over f of x squared minus a half is identically equal to 0. It means that this is identically equal to 1 for all x's within this interval. And then you see that I have a differential equation that I can solve and find f prime of x. So because what can I see? This is the famous combination, yes? So if I take integral from both sides, so this becomes integral of f prime of x divided by f of x squared dx from 4 to 8. The right hand side will also become okay, so let us not do that. Let us just find the primitive function, okay? So then it becomes 1 over 2x plus a constant which we don't know yet. But this one, I just already did it for you, yes? But not, here is just a indefinite integral. So what happens here, this becomes minus 1 over f of x. Why is that? Because if I ask you to differentiate this function, you will get exactly this combination. So the left-hand side is this, and the right-hand side is equal to 1 over 2x plus c, but I need to find c. Okay, I have two pieces of information. You need to use one of them. It doesn't matter which one you use. I have already checked them. It is consistent. So for example, let us use this piece of information. So I replace x with 4. So this becomes 1 over 4. So it becomes minus 4. And then if I put 4 here, it becomes 2 plus c. So c is negative 6. Yes? And c is negative 6, so I put it back here. So this means that minus 1 over f of x is equal to 1 over 2x negative 6. Finished, yes? Because now what is the question mark? The question mark is f of 6. So I have to replace x with 6. It's minus 1 over f of 6 equals to 3 minus 6 minus 3. So this means that f of 6 that I'm looking for is 1/3. Okay, so I have to admit that there is some caveat in this problem. I mean, there is something that you have to be careful. It should also be mentioned that the derivative is continuous so that I can really use this theorem. If that is not the case, in some way you can solve the problem without knowing that f prime is continuous. So it means that this problem is even harder. So I haven't thought about that part of it. So, but you can leave your comments to see how it goes. Because in principle, if a function is continuous and differentiable, there is no guarantee that the derivative of the function is also continuous. So that is one point that when I was solving the problem, I was not careful enough to see that point. But considering that f prime of x is also continuous, then f of 6 is 1/3, and of course I can see it among the options there, yes? And as you see, option D is correct. Okay, so I hope that this video was useful for you. I think the idea, regardless of if that I have done is true or not, but the construction of the problem was, I think, very beautiful to me, and I was very excited when I was able to solve it in this way. But right now I realize that I have been a little bit careless there. Okay, please leave comments to see how you think about the problem. Anyway, I hope that this problem was useful for you. Until the next video, be safe and goodbye. Thank you.